Thanks for joining. So today we'll present to you how we can improve the scalability of a platform, BPM platform like Bonita, using microservice architecture and serverless approach. So first, let me remind what Bonita Platform is. So Bonita is a platform to create a business application. So we can create business application, all the artifacts of a business application, the user interface, thanks to a UI designer based on HTML5 technologies, JavaScript technology, and Angular. We can manage our business data also, so store the data on a dedicated database, auto-generate as a REST API extension to access to the data. And above all of that, we have the process management. So Bonita Platform is the business process management platform. So the DNA of our platform is based on the process that will manage all the interaction between users and the systems. So we provide all the capabilities of an iterative development platform, so you can create the different artifacts and increment them, modify them incrementally on the platform, thanks to a dedicated add-on. So one of the big strengths of Bonita Platform is its extensibility. So you can extend every part of the platform itself. So the engine, the process engine itself. So if you want to change all the services into the engine, you can customize the access to the business data by extending the API that access to the data. And you can also extend the UI by providing your own widget and customize any behavior on the page. Sorry, I have a sore throat. So the architecture of the platform. So the platform comes with Bonita Studio, which is a development suite where we provide a studio to design your whole application, the business process, so Thomas will show you during the demo, and the UI designer to design the interface for all the tasks of the process. Then we can deploy all the application design in the studio into the Bonita runtime, which is the execution platform that will execute the different workflow, the BPM workflow, and also serve the UI created in the development suite. Moreover, the Bonita runtime allows to connect to any external system you need using the connector and extensibility capabilities. So, to summarize, Bonita Platform allows the business users, we use persona build here, to provide new innovation, new service to end users. And for that, the business users do not want to wait to have a platform ready to be used. So we want to ensure that all the platform will scale according to the new service we will offer to the end users. And so for that, the developer and the system administrator want to ensure the platform will scale automatically with the new application developed over the platform. So why scalability is important? Scalability is important because scalability will ensure that the business goals for the business users will be reached. And the business goal will be ensured if the quality of service of the application itself will be ensured on the platform. So we identify four main criteria for the scalability of a platform. First, it should be transparent to end users. Why? Because the end users do not want, for instance, to wait for a task to be available. They don't want to wait for a UI user interface to be displayed. They don't want to wait for an email to be sent on the platform. It should be automatic and dynamic, so the system administrator of the platform itself, the runtime, have to be easily deployable, easily configurable on the platform. They do not want to have to modify and do a lot of configuration and tips and tricks on the platform to ensure scalability. You should have a cost control of your scalability. It means that you do not want to oversize the platform immediately and to buy a big server to have the platform to run in a scalable manner. And it should be generated to all process type. It means that when the developer will develop all the artifacts of the platform, the UI, the different processes, etc., it will scale whatever the type of process is designed, whatever the user interface is designed. So the first two criteria can be met by managing the architecture itself. So regarding architecture, so we will use in Bonita, we have a strategy to use a microservice architecture. So what is the difference between a monolithic and microservice architecture? A monolithic architecture, you have a one core code base platform where everything is stored and everything is packaged at once. Whereas in a microservice architecture, we'll split your different platform services, execution services in different independent service that will collaborate and connect together to ensure the whole platform service and execution. So what does that mean for our platform? As you have seen in the initial architectural schema, I've put a big runtime. So we have launched a new strategy of what we call componentization of the platform itself. So we started to split the platform in multiple components. And for that, we use Docker technology. So all the components will be managed using an independent container that can easily be deployed. And when you have in a microservice architecture, of course, due to the multiple components you have to synchronize the deployment and ensure everything will be deployed in the right order and that everything will be connected correctly. So for that, we use Kubernetes technology, which helps us to deploy and interconnect the different connectors of the platform, the different containers of the platform. So what is the Bonita componentized architecture? Here is the first step of our componentization. So we split the portal part in multiple components. We group them into a pod. A pod is a deployment, group of deployment of container, but Thomas will show that later. And the engine also has been split in multiple components that can be deployed independently and ensure the scalability independently. So, thanks to microservice, we addressed the transparency to end user, I will see that later, and the capability to deploy easily and automatically the different piece of the applications thanks to this pod deployment that will be orchestrated by Kubernetes. We will show that during the demo. The two second aspect, cost control and genericity, can be addressed using the execution of the platform itself. So one of the main trendy approach to manage the execution cost is the serverless approach. So before we go in depth on serverless, so let me remind the Bonita Platform extensibility. So Bonita application is composed of plenty of custom codes. As you have seen in the second slide, you can extend the service itself, authentication service of the platform. You can extend, for instance, a connector. You can add some specific connector on the process, on the task. You can create your own business rules, which can be a big piece of code that can connect to external APIs or external systems. All this custom code made unpredictable the impact on the platform. So what is the pain of that? So it's due to this unpredictable execution, there is no way to know in advance the resource consumption on the platform. So it means that it's very hard to isolate the code because everything is initially stored on the platform and the platform itself will execute all the bits of code. And it limits the parallelism because the platform has to sequentially execute all the custom code. So serverless approach can help to solve this pain. So what is serverless? Serverless is an approach where you will develop an application without thinking at all about the infrastructure. Even in the virtual machine concept or container concept, you have to take into account the infrastructure itself and what you will deploy, how you will deploy it. With serverless approach, you just have to write a piece of code, ask a service to execute it, and synchronize just the feedback of this execution. So the main concept for serverless approach is what we call function as a service. AWS Lambda is the best or the well-known function as a service currently available. So when you will create a serverless application, your application will be composed of pieces of code, and some part of your code may be externalized and executed by the function as a service provided by AWS Lambda. So what are the advantages of serverless? First, there is no idle server, so you don't have to oversize your platform in advance because you will just pay for what you use. So the cost is linear. So when you will just pay when you ask the function to be executed, and when you get the feedback of the function, you don't have to pay anymore. Whereas in the usual infrastructure, you buy a big server, and your server is always available, and you have bought the server very costly. And sometimes when your platform does not do any compute nothing, and so you have paid for something that is not used. You can easily isolate your code execution and parallelize the execution itself. So you will let the service, the function of the service itself, manage the scalability for you. But unfortunately, it's quite complex because you will have to synchronize all the piece of code you execute externally. And so this asynchronism has to be managed by a strong platform. And this is where a BPM platform like Bonita can help to easily synchronize the different call to the different service, because all the extension point on the workflow execution can be delegated to an AWS Lambda function. So you can ask your function to be sent to an external function as a service, and manage the synchronization either by full synchronous call or asynchronous call using a callback message, for instance, on your platform. So, so when we combine both this concept, it will help to manage globally the scalability. Why? Because the microservice architecture will help us to manage the load on the platform itself, because you will be able to scale independently all the different services. But when you have to manage the cost itself, so you don't want to create multiple services that will require the big infrastructure, you can externalize some of piece of code to a serverless approach in order to manage the cost of your scalability. So to summarize, thanks to the combination of both this approach, we provide a platform that abstracts the complexity of the development. So all the persona implied in the business application development can focus only on the application development itself, rather than having to think about how the application will be executed and how it will impact the platform. So in the demo, Thomas will show you in the different steps how we can manage scalability. First, from a monolithic approach, then to a microservice approach, and then using the serverless execution externalization.
Okay, right. So let's start. We are going to start with this kind of platform. Like Philippe said, that this is a monolithic platform, and we are going to see what are the issues with this platform. So we are going to start with the processes. So here is what we call the studio, which is the place where you model your process. So we have this main process. It involves some kind of tasks which are automatics. But the main place here is that we have a human task. This means this is the place where the user will interact with the platform. In normal situation, when you have a platform which is sized correctly, the user are used to have their task coming in a regular flow, and everything run fine. But here in this platform, this is a shared platform, where we have other processes which are running. We have this kind of process. This process is a process which simulates document generation, and this kind of process generates a lot of CPU usage and is very time consuming. Usually, our customers are using this kind of processes to use the extensibility capability of the platform. We have different kind of extensibility points. Usually, we provide out of the box a lot of integration points, which allow to contact external service. But in a lot of cases, there is no external service, both in the company or available by provided by cloud provider. And so this extensibility point has to be developed and run inside the platform. For example, this can lead to have very complex kind of code, which is very costly in terms of resources. So I can show you an example of that kind of extensibility. Just to let you know that Bonita is running on JVM, so this is Groovy script. So that kind of code can be okay, but usually it's very costly. So what we're going to see is what is the normal flow for a user of this payroll process. So this is what the behavior of the platform when everything is running normally. Then we will inject, we'll simulate load on the platform, and we will see what is the bad impact for the end user of this load. And so thanks to the new way to manage the architecture, we can manage by to provide more computing capability, and this will make the end user life easier. And then in the last part of the demo, we will use function as a service to see that we can delegate the execution of this custom code, which is very costly in terms of resources, to the function as a service, and which will make the system administrator life easier. So, like I said, I will show you what is the normal behavior of the platform for when the user is managing his processes. So now I'm going to start the process I just previously showed you. Let's log in the platform. Okay, here you see the task list of the user. Okay, we are going to start a process, and we will see that the task will come very quickly in the task list of the user. Okay, so this is the normal behavior of a platform. So just imagine that the user are used to have this task coming in a normal flow, and then he can manage the task and do his normal work. Now we are going to see what's going on when the platform is subject to a high load. So for that, I will inject directly in the BPM engine the process which is generating a lot of load, this one, okay? And then we will see what's going on for the end user. So to inject the load, I use the gapping tool, which will simulate what is the impact of 100 of users on the platform. So now I go back, I start the process, I go back to the task list, and then we see that the task is not coming. So imagine a user which have to work, now it's blocked. So this, for the end user experience, is very, very bad experience. And so we have seen that with a lot of customers, and this is very painful for the administrator to let them understand what's going on. And this can lead for the user to completely abandon the solution. Okay, so maybe, okay, just tested. Let's maybe 10 seconds, 15 seconds, but imagine that with more and more load, and more users can lead to 20, 30 minutes, maybe hours. So this is the current situation, and now we're going to see what we can do to manage this kind of situation. So we start with that kind of architecture, it's a monolithic one, and then now we are going to see how we can scale horizontally. Basically, what we need to scale is the BPM engine part. Here is the front end part, which is deliver the UI we are not going to scale it because we have no issue with that. So what we are going to do is that passing from one pod, so one element providing the resources, to 3, and see if it's from the user point of view, it's better. Okay, like Philip said, we are currently moving to a Kubernetes orchestration solution. So just to let you see what is Kubernetes, here you can see the Kubernetes dashboard. This dashboard provides friendly UI where you can see what is the status of the cluster. Okay, here what we have. We have the front-end part. We are not going to look into too much detail, but here this is the BPM engine. As you can see here, we only have one pod, so one resource for that. And what I'm going to do is that to scale the platform. So I would like now to have 3 pods. Okay. So now the platform is going to scale. But what you have to keep in mind is that here in this demo, we are managing the scale manually because we want to control when the scaling is happening. But thanks to Kubernetes, we can manage this automatically, which concept is called pod autoscaler. This means that if you have some metrics on your application, you can decide when you want to scale automatically. This can be on the CPU consumption or any metrics. And this means when you define some gates, and when the gates are reached, the Kubernetes cluster automatically increase the number of pods you available for your solution. So now we should have what we have requested. So we should now have 3 available pods, I guess. Okay. So now we are ready to redo the same use case. I will inject the same kind of load and redo the task, and the user experience should be better. Just have a look on this. This is the CPU usage. Okay, this is going to be an indicator of the load we have when we inject previously the consuming process, and we will see right after if it changed or not. Okay, so let's go back. I will manage the task of the user. This is the previous one. And so now be ready to start one. Okay, I will just run the same simulation, load simulation. Okay, this is starting. Now we start the process. And we hope that the task, okay. So the task now in this case is available very quickly to the end user. So we have solved our first issue, that we have been able to scale the platform enough to make the end user life easier. So this is nice, but now we're going to see what is the impact on the overall platform, because it will come with a price. Actually, we have three times more resources. So this means that at a given time, we are able to consume 3 times more resources. This is what we see here. This means that we can scale, but we have a limited platform. So we won't be able to scale infinitely. So we have to find another way to reduce the load on the platform. And this is where function as a service can help us. Instead of performing the resource consuming task in the platform, we will delegate it to the function, and then we will reduce the load on this platform. This means that for the administrator of the Bonita platform, this administrator doesn't have to oversize the underlying resources he has, and then you can only pay the price when you need to perform the function. So to summarize this, what we are going to see is that instead we will just keep this platform with 3 pods, but instead of processing the costly custom code, we'll manage it here, the AWS Lambda. So, but what does that mean for the Bonita platform and the Bonita BPM modelization? Here, in this case, the process was managed locally. This is done by the extension point we call a connector. So now we are going to, instead of injecting load on a process which is running locally, we are going to use these new processes which will manage to execute the load on the AWS Lambda. For that kind of things, we have another what we call connector. This is the integration point which we will use in this case. So prior to inject the load, I will show you what kind of function we have. So let me log into the AWS platform. Okay, here we are. So in AWS Lambda, but also in a lot of functional services which are provided by cloud provider or even other solution, you can run locally on your data center. What you do generally is that you define your function. What you do is that you, instead of take the code you have locally and you put it directly here. And the main advantage of this kind of solution is that they are supporting a lot of language for that. So this means that you don't have to learn another language. For example, here we have a lot of language. The initial implementation was in Java, so this is not a problem to put the code here. But in the meantime, you can also leverage other solution that, because you have, as you have a lot of language, you can also use the knowledge of other developers and to implement differently the solution. Okay, now I'm going to inject the load with the new serverless processes. Okay, so this is going to take less time because we have more resources on the function as a service, and also we are managing this in an asynchronous way. This is the two key factors we have to keep in mind for such a solution, because in fact, what we have in the, when we are running the code locally on the platform, first you are using a lot of resources, but also you are, for the process like this one, which is time consuming, the time you spend to compute is not available for other tasks to be processed. In that case, what you do is that you just ask the function to perform the job, but you don't wait for the response. So this means that you don't have, you have more how do you say that? The worker which is underlying managing the process are directly available to manage another task. So here we are going to confirm that we have called the Lambda function. So this is the monitoring, the basic monitoring part of the Lambda function. Here we are, we have called it a lot. And now we are going to see what is the impact of our platform. So remember, this one was without scaling, with scaling, and now with the same scaling, but using the serverless function. Okay, this is this one. So what we have seen here, we have used two solutions to manage our initial issue. First, we have seen that our BPM platform is able to scale easily to make the end user life easier. And by using a functional service, we have make also the administrator life easier, and by reducing the load on the platform.
So what we try to show you here is multiple ways to manage scalability. So to manage the load itself using microservice and Kubernetes, and as Thomas said, using functional service. So both can be combined. They are not used for the same purpose. Microservice more for the load itself, whereas serverless is essentially used for managing the cost when you have some peak of load on your platform and you want to externalize this load. And so this is what we try to show you here. If you have a question, we are here also to answer. Thank you.